Okay, this is the last section in chapter 12, 12.7, and 12.7 deals with solving radical equations. Up to this point, we've been doing um, either multiplying or dividing radical expressions or adding and subtracting. We're going to use both of those elements in this section to help us solve the equations, which means in the nutshell is we're trying to find what x equals. So with that, one of the main things that we're going to be doing, which is to solve for x, is cross multiplying. It's very similar to problems you may have seen, something like this, where you have x over 2 equals 5 over 10. And if you cross multiply, you have, it means you're multiplying these two together, which makes 10x, and then you're multiplying these two together, which then gives you 10. Then you divide both sides by 10. In this case, your x would equal 1. And so you're going to be doing things like this today, but you're going to have to remember to be careful when you cross multiply to distribute if need to. Looking at example A, we're going to solve for these two radicals, which we have 7 over x minus 2 equals 11 over 2x minus 10. So we have two fractions, so we're going to do the cross product. So I'm going to multiply these two together, and I'm going to multiply these two together. So I have 7 times the quantity 2x minus 10, so that means that I'm going to write it as 14x minus 70 equals, here I have 11x minus 22. It's basically like if you're just taking the 7 and distributing it like this, and also the 11, and you're distributing it here. That's where I get those values from. So I'm going to subtract 11 to both sides. So that cancels out. So now I have 3x minus 70 equals a negative 22. So now at this point, it's just algebra trying to solve for x. So I'm going to add 70 to both sides, which then that gives me 48 equals 3x. And if I were to divide both sides by 3, that gives me x equals 16. And it's very important to check your solutions, see if it works. So let me get rid of this lines here. Okay. And I'm going to place 16 in for x. So 7 would be what? 7 over what? 16 minus 2 is what? 14, which then equals 11 over 2 times 16 is what? 28. And no, 32, I'm sorry, 32. And 32 minus 10 is 22. And if I were to reduce this down into lowest terms, it'd be 1/2. And so it would also be 1/2. 4, 11 over 22, so it checks out. Looking at our example B, we're going to do the exact same thing. We have 6 times quantity x minus 5, so I have 6x minus 30 equals 2 times quantity 3x plus 4, so I got 6x plus 8. If I subtract 6x to both sides, in fact, those gives me 0, so I'm left with negative 30 equals 8. And since that's not a true statement, I can come to the conclusion that this is no solution. There's no solution for x that would make this a true statement. Now, those are some of the less challenging problems. Let's get into some more complex ones. And the reason why they're a little more complex is you have to find a least common denominator. And if you look in example A, the right side of this equal sign has two separate terms, which could be fractions. This could be a fraction that's, so it's like 1 over 1 minus 12 over x. And what I want, my goal in this case is I want to be able to combine those terms so I can cross multiply like I did for the examples up top. So the right side of my equal sign is where I don't have an equal denominator. So I'm okay on the left hand side, so I can rewrite this as x plus 7 equals, now what will give me a common denominator is I can multiply both denominators together to make them the same. So 1 times x leaves me with x. So my common denominator is going to be x. So, but the thing I have to keep in mind is whatever I did to the denominator in this particular fraction, I must do the same thing to the top. So for this one, I multiplied the denominator by x, so that means I must multiply the numerator by x. The second one, I didn't do anything to, so I can leave that the same. Now, I can combine those two fractions. Well, this one stays the same, 12 plus 7x equals, and this one is x minus 12 all over x. Okay? So now, with that in mind, we can go ahead and cross multiply. I got 12 times x equals, I got x plus 7 times x minus 12. Okay? So, what I'm going to do to the right-hand side of this equal sign is I'm going to FOIL this out. So that leaves me with x squared. So that gives me what? I got 7x, and then I got negative 12x. So that's what? Minus 5x minus what, 84. Okay. So that means that I want to set my left hand my left hand side of the equal sign equal to 0. So I'm going to subtract 12x to both sides, which gives me 0 equals x squared, and then negative 17x minus 84. Okay. So let's see. Can this be factored? So if I have 0, can I reverse FOIL this? It's x. I got x. This negative here means it's going to be different signs. And they need to find values that products are 84, but the difference is 17. And I believe I can find it with 21 and 4. So if I use the zero product property, my x can equal -4 and my x could equal 21. So once I find values for x, I must then put them back into this original equation to see if they hold true. So if I remember what x is -4 and 21. So what I'm going to do now is place them back into the original equation. So I have, let's deal with x equals -4. So the first one is I got 12 over 3, which ends up equaling 4. So my left hand on this equal sign will equal 4. Now I have 1 minus, what was it, 12 divided by a -4, which gives me a -3. That goes plus plus, so that equals 4. So -4 checks out, so we're good there. Now let's take a look at 21. So I have 21 plus 7. So I got 12 over 28 for the left-hand side of the equal sign. And that can be reduced down to 3 over 7. So now if I look at the right-hand side, I got 1 minus 12 divided by 21, which that ends up being 4 over 7. And 1 minus 4 divided by 7 equals 3 over 7. So those hold true. So both values hold true. Not all the time you're going to find that both values hold true. Sometimes you're going to have both values be true. Sometimes you're just going to have just one. And sometimes you're going to have neither of them. So it's very important to check for extraneous solutions. Last example, let's look at B. We got 7 over x minus 1 all minus 5 equals 6 over x squared minus 1. Okay, so in this case, the left-hand side of the equal sign doesn't have a common denominator before we can cross multiply. So let's see what we can do. We can imagine this as like minus 5 over 1. So if I were to multiply both of these denominators together, we can conclude that the least common denominator is x minus 1. So I didn't do anything to the first fraction, so I just leave that as 7. But the second one, I multiplied the denominator by x minus 1, so I must do that to the top. Equals 6. And just for this sake, I noticed that x squared minus 1 is the difference of two squares, so I'm just going to write it as x plus 1 over x minus 1. I'm going to combine the two fractions on the left-hand side of the, well, actually, first thing I'm going to do, before I do that, I apologize, I'm going to factor, or I'm going to distribute that 5 over the x minus 1, which leaves me with 7 over x minus 1 minus 5x minus 5 over x minus 1 equals 6 over x plus 1 over x minus 1. Okay, now I can subtract both of them to make them one fraction, so I know that the denominator doesn't change. It's going to be x minus 1. I have a minus 5x, so I'm going to have a negative 5x, and it's going to be 7 minus a negative 5, so that leaves me with plus 12 equals 6 over x plus 1 over x minus 1. All right, now that I have one fraction on each side of my equal sign, I can then cross multiply. So I'm going to go 6 times x minus 1 equals negative 5x plus 12 times x plus 1 times x minus 1. I notice that I have an x minus 1 and an x minus 1 on both sides of my equal sign, so it would just be like dividing both sides by x minus 1, and those cancel. Okay, so that means I'm left with 6 equals, and what I'm going to do is I'm going to FOIL this out here, so that leaves me with negative 5x squared minus 5x plus 12x plus 12. I can combine like terms here, which gives me 6 equals negative 5x squared plus 7x plus 12. And what I'm going to do now is shift, because I like to have my x squared to have a positive number to it. I'm going to move everything to the left hand side of my equal sign, which then leaves me with 5x squared minus 7x, and then it's going to be 6 minus 12, so that's what minus 6 equals 0. Now, I can't think of values that would factor out, and if you cannot, you can always resort to quadratic formula. And to refresh your memory, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And so if I were to plug in those, so my negative b, which would be a positive 7, plus or minus the square root of b squared, which is 49, minus 4 times a, which is 5, and times c, which is negative 6, all over 2a, which is 10. So I got 7 plus or minus square root, so I got 49 minus, so I got negative 6 times 5, which gives me a negative 30, times by 4, which gives me a negative 120, so actually that becomes a plus all over 10. And 120 plus 49 equals 169, which ends up giving me the square root of 169 is 13, so it's 7 plus or minus 13 all over 10. So 7 plus 13 divided by 10, so x could equal 2, and 7 minus 13 divided by 10, which would equal, what, negative 0.6, and if that's a fraction, that's what, negative 3/5. And then all you'd have to do is test to see if x equaling 2 and x equaling 3/5 would work in the original equation. And that is how you solve radical equations. Hope this helps. Until next time.